rotation, we eliminate 1 torque.
Why do we not have friction acting on the top of the ladder against the wall?
Because then that makes the problem unsolvable. It's a lot trickier there because realistically there's 2 different static coefficients, and you really don't know how much, if we exceed this static, is this enough still to hold it in place? It becomes far more complicated. We will assume it's a somewhat new ladder, and ladders typically have rubber feet at the bottom or something to hold it in grip, and then sort of wheels up here so that it moves relatively, at least compared to that, easily. So that's why. After I actually found a paper where somebody addressed that, and I've only gotten partway through it. Anyway, so that eliminates 1, and we can pick that spot certainly. You're pointing, to him, Riley.
If we put the axis where y1 and f is, can we eliminate both of those?
All right, we eliminate 2 there. There's actually a couple of other spots which would eliminate 2. I don't think there's any spot that eliminates 3. What are the other spots that would eliminate 2 torques? Hence, since it's in static equilibrium, it really doesn't, we can pick the spot anywhere. I'll go ahead and spoil it. Here. The axis of rotation doesn't actually have to be on the ladder itself. If we pick that spot, then there's no torque from the weight of the ladder, and there's no torque from the friction. I can pick this spot up here. There's no torque from Y2 and no torque from Y1. I can pick here, although that's a lot more difficult because I do have an unknown thrown in there, but I don't have anything from the weight of the person or from the friction. So there are other spots not on the ladder that can be picked. Now, I have no problem picking any of those. So given all that, where do you want to pick it? Should we go with the first thing that was said? Does not seem to be any objection. There we go. All right, so we will pick the middle. That is our axis of rotation. So now, I'm going to have, so I got torque Y1 plus torque F plus torque. I'm going to put WL in there, but that's going to be 0 plus torque. I'll list it as WP plus torque Y2 is equal to 0. Technically I times alpha, but alpha is 0. 1, 2, 3, 4, 5. All right, so those are my torques. That's just generic, some of those torques. I know this is equal to 0 because the moment arm is 0. Now directions. Y1. If we assume we established I had J hat, which way is K hat? If I hat's to the right, J hat's up. Which way is K hat? Yep. That's J. So Y1, is that a positive torque or a negative torque?
Positive torque.
How'd you get that?
I started from friction and then went this way.
Start with friction, I asked about Y1.
Oh.
If this were, imagine I had a propeller here and I had my axis of rotation here. Y1 is going to try to rotate it which way? That way. So it is into the board, which is negative, so that's going to be a negative number. What about friction? Which is, yeah. What about the person? I'm not quite sure which way that, you're picturing it differently than I am.
Okay.
Your thumb should be pointing into the boards or away from the board. All right, so the way I've drawn it right here, if that's my axis and I'm pushing down there, then trying to rotate it like that, so that into the board. And then Y2. That way? Is that what you're going with? I'm trying to figure out what your gesture was. You're not sure, okay. Out of the board? And again, if this is my feller right here, and I push on it that way, that's trying to rotate it around like that. So it will be out of the board. Obviously, I've left some gaps there.
Can you explain the person again? How did you get it?
Again, if this is my pivot point right here,
Yeah.
and I'm pushing down like that,
Uh-huh.
it would cause this thing to rotate this way.
Yeah.
So, into the board. Did I put positive over there? No, put negative. You have an issue though.
I'm just trying to. All right.
Now, we have the directions now, so we've thought through that. We have the directions. We don't have to worry about cross products other than we do need to worry about the magnitude. If we talked about before, if I have A cross B, the magnitude of that is going to be the magnitude of A times the magnitude of B times the sine of the angle between them when I put them tail to tail. So what I'll end up with there is I'll have, for y1, I'll have negative y1 times the length, which is L over 2, and labeled specifically capital L there, so it's L. Times the sine of the angle between them. Well, y1 is going this way. My moment arm is from the axis of rotation to where the force is applied, so my moment arm is going this way. If I put them tail to tail, that's the angle I want. I know that that is a 57-degree angle. Therefore, that is a 57-degree angle. That is a right angle. So the total thing is 147 degrees. Dramatic pause for people to absorb that and ask questions.
Oh, we don't know that the wall and the ground is a right angle? Is that what?
No, we do. When you're doing a cross product, you want to multiply perpendicular components. I have y1 going this way. I'm doing R cross F. R, the moment arm, is from the axis of rotation, which is somewhere around here, to where the force is applied. So basically a vector like that. When I'm looking for that angle, so the magnitude is R times F times the sine of theta, I put them tail to tail. So y1's going up, my R is going this way. I need to know that angle. It's the sine of that angle.
I think the thing that's confusing me is that 147 plus 53 is like,
No, the 147 is 53 plus 90.
okay.
Because the one angle that I give you is, I give you that angle.
Oh,
That's a 57-degree angle. I then took this one and I sort of broke it up. That's also a 57-degree angle. That is a 90-degree angle. So the whole thing is 147.
Okay,
All right.
sorry.
So times, not today, or at least not yet, 147. Plus the torque from the friction. Well, it's going to be the magnitude of the friction times the distance, L over 2, times the sine of whatever angle that makes. Not 147. Friction is acting this way. My moment arm is acting that way. So this is my friction, this is R. If I put them tail to tail, that is the angle I want. I know that is a 57-degree angle. I know that is a right angle. This is the complement of 57. It is a 57, yeah. So that's a 33-degree angle plus the 90, 123 degrees. Dramatic pause for questions. All right. Minus the torque from the person. So it's the magnitude of the person, WP, times the distance. What is the distance between the person and the ladder and the midpoint? What's the length of my moment arm? What's the distance from the bottom point to where the person is?
I would like to. I would like to.
No.
Is it X?
X. What's the distance from the bottom point to the axis of rotation?
Oh, that's how I would like to.
Yeah. So the difference is X minus L over 2. So I'm just looking for that distance right there. Now I'm making the assumption, I'm doing this assuming that X is bigger than the halfway point, that we're past the halfway point. If I'm wrong, if X is less than the halfway point, then this becomes a negative number, which means that that negative is going to cancel out with that negative, which means that the torque is going the other way, which it would be. Because if he is below the axis, if he's down here, then he would be trying to create positive torque. So the mathematics is going to work out. Times the sine of that angle. Well, let's go through and figure that out. So my moment arm, so my weight's acting down. My moment arm is acting up. So if I put them tail to tail, that's my weight of the person, and this is the moment arm for the person. I know that's a 57-degree angle. So the whole thing would be 147. Plus the torque from Y2. So that's the magnitude of Y2 times the distance, which is L over 2, times the sine of, well, let's figure out what that angle is then. So Y2 is going this way. Y2 is going to the left. R is going up at a 57-degree angle there. So the angle between them.
180 minus 557.
Yep, 123. Now let's see how many unknowns we have. I don't know F, I don't know Y2. I can figure that out easily enough. I don't know Y1, but probably stick with the same convention there. So I don't know that. I can figure those out. So that's 3 unknowns, and I don't know X. I have 4 unknowns here and 3 equations. What else do we need in order to solve this? Besides the 4th equation. All right, so let's do substitution phase. Maybe that will clear some cobwebs there. What are we going to substitute?
Y equals mg.
All right, so I've got ml times g. Here I'm going to have m person times g.
For friction is static times normal force.
Yeah. So this is going to be use of S times normal force. Which one?
1.
So I need to give you use of S. Oh, I gave you use of S. There we go. So now I'm down to 3 unknowns. We can solve this. We can do it. I need to get to a new board here. And this part over here I'm going to need help with. But anyone still writing down before I...
Is that a plus before Y2 at the bottom?
Yes, that's a plus.
Okay, and is that 6 sides of plus and minuses?
Wait, where are you?
Left bottom. Is that a 6 left bottom?
Left bottom.
Plus,
That?
plus 0? Yeah.
That's a 0.
Okay.
Another fox, is that a mu of S Y1?
Yes.
Okay.
So what are the 4 unknowns, like the 3 check marks and what's
The
left?
4th, we didn't know friction, Y2, Y1, or X. Those were the 4 unknowns.
X. Got it.
But when we did the substitution, we related force to Y1, and so now we have only 3 unknowns.
Oh, okay.
I was thinking I hadn't given you use of 3, I'd forgotten already, or use of S. Again, I'd be worried. I haven't been doing that all my life. All right, so we have use of S times Y1 equals the
No, minus Y2 equals 0.
okay.
Oh, I don't know, sorry.
The next one we had Y1 minus MLG minus MPG equals 0. And then the long one is negative Y1L over 2 times the sine of 147 plus so US Y1 times L over 2 times the sine of 123 degrees minus, then we get to weight of person, so that's MPG times X minus 1/2 L times the sine of
147.
right here, plus Y2 times L over 2 times the sine of 123, I think it was, equals 0. Blank jug. Now, at the point to put in numbers is up to you. Again, it's generally recommended when you're teaching it, don't put the numbers in at the very end. However, that's sort of a mess there. Let's see how we can simplify it by putting numbers in. This is y1. Okay, so from the first one here, I have 0.3 y1 equals y2. From the second one, I have that y1 is equal to mass of the ladder times 9.8 plus mass of the person times 9.8.
Why is it plus?
When I bring these over to the other side, you have to add them both.
Oh, okay, I got it.
So 78.2. No, that's not right. What is it? 19.4. I think that's right. Oh, sorry, 784.
Yeah.
I was like, I'm so off, and I kept doing it. I was like, I don't understand.
What's a decimal point among friends?
Right.
So now that I know what y1 is, I can plug into here to figure out y2. So this is going to be 0.3 times 784.
235.2.
One more time.
235.2.
235.6.
2.
0.2?
Yeah.
All right, 235. So I know what y1 and y2 are now. I know what the friction is now. All I'm missing is x. So let's plug and chug down here. So I have negative